Welcome to This Explainer. Today, we are tackling literally the biggest headache in AI, how to build an application that actually knows your specific data. We're going to break down exactly how to stop these language models from just blindly guessing and instead force them to give you factual, verifiable answers every single time. So let's start with a kind of uncomfortable truth. Your AI chatbot? Yeah, it's lying to you. Now, it's not malicious, right? It's not sitting there trying to trick you on purpose. But when an AI simply doesn't have the information you're asking for, instead of just throwing its hands up and saying, hey, I don't know, it confidently hallucinates. It makes something up that sounds incredibly plausible. And this tendency to just confidently invent facts, it isn't just some quirky little bug. It is, without a doubt, the single biggest roadblock preventing companies from trusting AI with real enterprise-level work. Okay, so here is our roadmap for today. First, we'll unpack the hallucination problem. Then we'll introduce the RAG solution, break down the two-phase architecture, actually build out the pipeline, and finally, look at how to avoid some common mistakes. Let's get right to it. Section 1, the hallucination problem. Let's really look at why these language models are lying in the first place. Here's the deal. Language models are essentially frozen in time. They have a strict training cutoff, so they hit this massive knowledge wall the second you ask them about your own proprietary or internal company data. And instead of just saying, I don't know, they hallucinate. They generate this fluent, highly confident, but completely wrong answer. Now, I really want to emphasize this. The model is not doing this to deceive you. It fundamentally operates by just predicting the next most likely word based on its past training. It's really just trying to be helpful by filling in the blanks of what it doesn't know, which, is a feature by design, but it becomes a fatal flaw when you need absolute 100% reliability. And that brings us to Section 2, the RAG solution, or Retrieval-Augmented Generation. The best way to think about traditional AI is like a student trying to take a massive final exam purely from memory. RAG, on the other hand, is like giving that student an open book test. Instead of forcing the AI to just memorize everything during its initial training, we allow it to look up the exact correct information just seconds before it answers you. Now, there's a massive misconception in the industry right now that to teach an AI your company's facts, you absolutely have to fine-tune it. But fine-tuning really just changes behavior. It teaches the model how to talk, not necessarily what facts to know. Plus, it's incredibly expensive, it's slow, and honestly, if your data changes tomorrow, you have to retrain the whole thing. RAG changes the knowledge itself by keeping your facts securely in an external database for live retrieval. To put it simply, fine-tuning is for style, but RAG is for facts. Moving on to Section 3, the two-phase architecture, specifically indexing and querying. This whole system becomes so much easier to digest when you split it into two distinct phases. Phase 1 is indexing. Think of this as organizing a massive library before anyone even arrives. This prep work happens ahead of time, usually just once, or whenever your underlying documents happen to change. You basically take your raw documents, think PDFs, manuals, whatever you have, and you shred them into small, manageable chunks of text. Then you convert those chunks into mathematical vectors, which we call embeddings, and you lock them safely in a database. Boom, your library is now indexed and ready to go. Now, phase 2 is querying. And this is the part that happens live. Every single time a user asks a question, you convert that specific question into an embedding too, and instantly search your database for the mathematically closest chunks of text. You grab those matching chunks, shove them directly into the prompt right alongside the user's question, and then the language model reads that context to generate a perfectly grounded answer. The absolute golden rule here, retrieval always happens before generation on every single query. Let's get into the nuts and bolts in Section 4. Building the pipeline, and taking a look at the actual tech stack. If you want to build this yourself, here is the exact production-realistic stack the pros are using right now. We've got Python to build the core logic, LangChain to orchestrate the flow of data, OpenAI's text embedding 3 small to create those mathematical vectors we talked about, ChromaDB to store them locally, and GPT-4o Mini to actually generate the final answers. It is remarkably simple, highly beginner-friendly, but still completely robust enough for real-world applications. Now, during that indexing phase, you're going to hit a really critical tuning knob, and that is chunk size. A proven sweet spot in the industry is about 800 characters with a 100-character overlap. Chunk size is a really delicate balance, right? If your chunks are too small, you completely lose the context of the thought. But if they're too large, you dilute the relevance and totally confuse the search algorithm. That 100-character overlap, that is your safety net. It just ensures a vital sentence doesn't get accidentally sliced in half between two different chunks. But honestly, the absolute magic of this whole system happens right inside your system prompt. You absolutely must explicitly instruct the AI with something like answer only using the given context and explicitly say when you don't know. This single straightforward boundary is a total game changer. It prevents the model from blending in its own trained knowledge and forces the AI to look at the specific chunks you retrieved and literally nothing else. If you skip this instruction, you are going right back to Hallucination City. Which brings us to our final part, Section 5, avoiding common mistakes and really making this system reliable. Look, getting a basic RAG demo to work is pretty easy, but making it bulletproof, that takes some real engineering. For instance, if your chunks are cutting off mid-sentence, you need to switch to structure-aware splitting. Break it down by paragraph or heading instead of just random character counts. Also, to really build user trust, you should always return the source metadata so the user can verify exactly which page the answer came from. If your AI seems to be missing context, don't just stick to a fixed retrieval number. Grab a larger batch of chunks and use what's called a re-ranker to find the absolute best ones. And if the AI is still guessing, double-check that you didn't accidentally ignore that "I don't know" rule in your prompt. Finally, remember that embedding models are not one-size-fits-all. Always test out different models tailored specifically to your domain, like legal or coding text. Now, I know what some of you are thinking. What if API costs or data privacy are complete deal breakers? Well, you don't actually have to rely on cloud providers at all. This entire architecture works beautifully locally. You can easily swap in something like sentence transformers for local embeddings, run models like Llama 3 or Mistral directly on your own hardware via a Llama, and just keep using ChromaDB. You get the exact same robust architectural results, but your data literally never touches the cloud. So there we have it. We've mapped out the hallucination problem, explored the two-phase RAG solution, looked at the exact tech stack you need, and covered the expert fixes to make the whole thing bulletproof. The era of blind AI guessing is officially over. The only question left for you is this: what critical application are you going to build now that your AI can actually be trusted? The blueprint is in your hands. Thank you so much for joining me on this explainer, and I absolutely can't wait to see what you build.